So what we're going to do here is go back to the graphing method, but do it with inequalities. I want to start with a basic one and teach you kind of how to do inequalities if you've never graphed one before. Y is less than negative 2/3 x plus 4. What we're basically saying here with this statement, and you need to read this, is that the y value and the y value on a particular graph refers to the up-down, but the y value is less than the line. So when we say the y value is less than the line, and we graph a line, I actually mean that the y value is going to be down from there. It's less than, it's smaller. And that's what less than means. Greater than means the other side. This particular interpretation only works when we have the y on the left side and the line on the right side. So let's go back to this example, y is less than negative 2/3 x plus 4, and go through the steps on how to graph it. I'm actually going to put the graph below. And you know what, let's change the grid to be just a little thicker or bigger so we can see it better. And we're gonna put a grid below, and on the right side I'm gonna put sort of the little reasons why, or the little steps. So step 1, put in slope-intercept form, being really careful about the sign flipping thing that we're gonna kind of see here in some later examples. So put in slope-intercept form. Step 2 is to graph the borderline. And I'm going to put graph the borderline with a solid or a dashed line. Solid lines occur when you have a less than or equal to, a greater than or equal to, or an equal. And dashed lines occur with less thans, equal thans, and even not equals, which we will deal with kind of later in life. So this particular graph, if I graph the borderline, it has a y-intercept. Remember that the 4 represents the y-intercept. It's a y-intercept of 4. And the graph's slope, the negative 2/3, goes down to right 3, and we can just keep going down to right 3 until we kind of cover the graph. So I don't have too many points here, but that's okay. I can even stick little half points in between here if I want to get a better thing. We're going to graph this with, since this is a less than, I'm going to put a dashed line because it's a less than. So dash, 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 and sort of the whole way. It's important not to make this a solid line. It has to be a dashed line. Step 3, decide if shade, above or below line. For y is less than, or y is less than or equal, we shade below. And for y is greater than, or for y is greater than or equal to, we shade above. So y is less than, this is a y is less than, and we're going to shade below. I want your shadings just to be straight lines, though, like perpendicular to the actual thing. The reason is that we're going to have multiple on the same graph, and we might want to cross them. So there's my shading, Georgetown colors. And that's it, except let's do a step 4, which is test an ordered pair that is not on the border. So let's pick an easy ordered pair to test. For example, let's test 0, 0, which only works if 0, 0 is not on the borderline, and in fact here it's not. So I'm going to pick that point, and I'm going to plug it back into the original. So when I say test, I mean plug in original inequality. So I'm going to go y is less than negative 2/3. Actually, it shouldn't be y, it should be 0 is less than negative 2/3 times 0 plus 4. And I get 0 is less than 4, and this is true. Then I'm going to say since 0, 0 is in the shaded region, I would expect it to be true. Okay, so that's a lot of notes for you, but that's kind of the idea behind what we're doing. Let's do another example, number 2. Let's try y is greater than or equal to negative 1/5 x minus 4. Actually, you know what? Let's change the minus 4 into a plus 2. Okay, yes, that's what I want. Okay, so step 1, put it into y equals form. It already is. Step 2, graph. So I'm going to go plus 2, negative 1, right 5, up 1, left 5. Put a half point here and a half point here so I can connect better. And I'm just going to put, got a straight line. So I am going to connect a straight line all the way out here because I have to click in. So then we've got a straight line. I'm going to go, let's see, shade above or below. Well, this is a greater than, so I'm going to shade above. Let's shade above like this. Woohoo. And now we're going to test a point after I'm done shading. Let's test 0, 0 again, which is right here. Now, here I'm testing it in a region I didn't shade. So what I'm going to say is, since 0, 0 is in the unshaded region, I expect it will be false. I just wanted to give another example of one that won't work. So we go 0 greater than or equal to negative 1/5 times 0 plus 2. Or 0 is greater than 2. And that is actually a false statement. But I expect it to be false. So that works. 0, 0 should be false. And thus it passed my test. Okay, let's go to number 3. New example, double problem. So we're going to do, let's go negative x plus 5y is greater than or equal to negative 2. Oh, kidding, let's do negative 10. Sorry, I'm looking at something different. Then let's go 3x minus y is greater than negative 4. So the first thing I want to do is convert both of these to slope-intercept form if I'm going to graph them. So the top one, I'm going to work kind of to the right, and this is okay because I'm trying to keep these lined up. So we're going to put a little arrow, and then I'm going to say this is 5y is greater than or equal to x minus 10. And then I'm going to put a little arrow and kind of keep this going, divide both sides by 5, and I have y is greater than or equal to 1/5 x minus 2. Remember, x over 5 is the same as 1/5 x. The bottom one, I'm going to get negative y is greater than negative 3x minus 4. And then when we divide both sides by a negative 1, or multiply both sides by a negative 1, I get y is sign switches less than 3x plus 4. So that's an important thing to remember about the sign switch thing. Okay, up here I have a slope of 1/2 and a y-intercept. I'll just put y-intercept of 0, negative 2. Here I have a slope of 3 and a y-intercept of 0, 4. So we're going to want to graph both of those lines. Now, for this particular problem, because of the confusing nature of it, I do want you to label your lines. So I'm going to call this maybe line A and this line B, just so you don't have to rewrite them if you don't want to. But let's graph line A. Y is greater than or equal to 1/5 x minus 2 would be here. 1/5 is up 1, right 5, or down 1, left 5. I know that it's a solid line, and so I'm going to connect the solid line. Actually, I have to do this as array because it otherwise really wants me to click into points. And then I have to do like this as array here. This is actually kind of annoying. Come on, Here we go. Okay, so there's the line. That's the first one. That's line A. And let's finish graphing that. What's greater than? Greater than is up. So we're going to shade up. Now fill the graph and make them perpendicular. And you'll see why we needed these to be perpendicular. Okay, for those of you who like multiple colors, this is a good time to change colors. I'm going to change to maybe a... Oh, let's go orange. Let's go pure orange to go complementary. Okay, that's not pure orange, but... Okay, there's pure orange. Alright, so we got that one. Now let's do line B. B is y is less than 3x plus 4. So I'm going to go up 4, put a point, then up 3 right 1, down 3 left 1, continue for the entire grid. And I'm going to graph this as a dashed line. So put a dashed line. All the way down. Now, are we going to graph above or below? Well, that says below because it's a less than. So below this line is actually to this line's right. And we're going to graph perpendicular lines to that one. And keep those going. Then, I'm actually going to take a highlighter, and I'm going to highlight the region that's in common, which is this one. That's the region where our graphs overlapped. Then I'm going to take a dark marker, and I'm going to trace. Wherever it was dashed, it's going to stay dashed. When it intersects, I'm going to put an open circle there. Open circle because I'm intersecting a dashed line with a solid line. So I don't want to actually include that point. But I do want to include these here. I'm going to trace this over with a darkened line. Then finally, to be absolutely clear that this is what I'm talking about, I'm going to circle this and say, this is where I want you looking. So that's the solution. Any point in that region solves both inequalities. Notice how I didn't test a point. You could. You just have to test them individually. But that becomes an exercise in, one thing you can do is pick a point that's common to both, like maybe 0, 0 here. It's actually in the region we want, and just plug it into both. So if I plug into the original A, I get 0 is greater than or equal to negative 10, which is true. If I plug it into the original B, I get 0 minus 0 is greater than negative 4, which is also true. And since I picked the point that's actually in the region, I expect it to be true. So that's a good way to check, just to pick a point in that region. But they won't always be sure you're right. Just make sure you're not wrong. Okay, number 4. Let's do y is greater than or equal to 1 minus 2x, and x minus y is greater than or equal to 2. So like we said, I'm going to put this in left brace and do an arrow and make sure they're both in slope-intercept form. Y is greater than or equal to negative 2x plus 1, and negative y is greater than or equal to negative x plus 2. So let's carry that over one more time. Y is greater than or equal to negative 2x plus 1, and y is, change the sign, less than or equal to positive x minus 2. Let's make the minus 2 in black to match. Actually, the x part too. Sorry, I'm being picky. Come on, computer. Let me erase. There we go. So, now we graph. We're going to call the first one A. I'm going to do that one in blue again. But let's put the grid in black. (2x plus 1), that'd be, do I really need to do m is equal to negative 2 and y-intercept is 1? I hope you guys are okay with that. Actually, it should be 0, 1, just to be correct with the ordered pair. And this is slope is equal to positive 1 with a y-intercept of 0, negative 2. So for the first one, I'm up 1 for the y-intercept, then down 2, right 1, up 2, left 1. I'm going to continue to put points all throughout the entire grid. Go back up. Is it a solid or a dashed line? It's a solid line. So I'm going to use my line tool and connect those. Ooh, wait, I want it blue. Let's go blue, line tool, connect. Then we shade above or below. This is above. So I'm going to point these to the right here, which is above the line. And we'll move on to the next one. Once again, I'll change colors to orange. Okay. X is less than, we have x minus 2, so minus 2 is here. Slope of 1 is up 1, right 1. Oh, nice. Well, I guess I'm going to have to finish quickly. Up 1, right 1. Oh, no dash line. This is actually a solid line. If I go up 1, right 1, and put all those points, I can actually just use my line tool and connect all the diagonals here. So I have a slope of 1. This says I shade below, so shade to the right. Take your highlighter, highlight the regions where they cross. Take your black marker, trace along the solid. We have the intersection of two solids come up here. So if I do that, I actually have a closed circle, not an open, because it's two solids coming together, and then branching off down here. That is a terrible trace, but hey, who cares? Furthermore, if I were to ask you, what is the border point? You should be able to look at that and say, well, the border point is 1, -1. That's just a question that I could ask you, so be ready for it. And we're done.